Continuing with multiple choice practice test, this is number 20. What are all the values for which the definite integral from -3 to k of x squared is equal to 0? So essentially we're asking, when is the area going to be 0 from -3 to whatever the k value is? So here's x squared, which is a parabola. So if we're starting at -3, whatever this area is, if we continue, it's just going to get larger and larger, right? There's no negative region that's going to cancel out this. So the only place that's going to still be 0 is if the bound is, if the end bound, if k is also -3, because from -3 to 3, from -3 to -3, we haven't moved at all, so there's no area for us to find. So our k value is -3. Okay. Another way that we could do this is we could work this out and solve for k. So that's if I find the antiderivative of x squared, that becomes x cubed over 3. We plug in our upper bound minus the lower bound. So we get k cubed over 3 minus a -3 cubed over 3. -3 cubed is -27 over 3 is -9. The two negatives become positive. We move the 9 over to the right side. We get k cubed over 3 is equal to 9. Sorry, is equal to -9. Cross multiply, we get k cubed is equal to -27. And take the cube root of both sides, we get k equals -3. It's a longer way of doing it, but this is also a way for us to kind of work it through by hand and just for extra practice. But if we can see that the area is going to be 0 as long as we have our starting and ending bounds being the same, then that's a lot faster. Number 21, we have a derivative equation, and we're going to be finding y by solving this differential equation. So I'm going to start off by cross multiplying here. dy over dt equals ky over 1. Cross multiply, get dy is equal to ky dt. I want to separate the variables, so I'm going to move the y over to the left side. Divide by y. And now we can take the antiderivative of both sides. We have 1 over y dy, which is natural log absolute value of y. And the integral of k dt becomes kt plus c. We raise both sides, base with e as the base. This cancels out nicely. We have y is equal to e to the kt times c. We can push the c out in front, drop the absolute value. So we know our equation is going to be in the form of ce to the kt. So out of the answer choices, the only one that is going to fit that form is part B, where if we can imagine if c was 2, this would fall under that category. Y equals 2e to the kt. All right, 22. Function f is given by f of x. On which of the following is the interval of f increasing? So if we want to find out when the graph is increasing, we are going to apply first derivative test. We're going to find f prime. We're going to set f prime equal to 0. Find the critical points. Create our f prime sign line, and then we're going to test intervals within the sign line. So from f, we're going to find f prime. So we go through power rule, 4x cubed plus 2x, set equal to 0. We can factor our 2x out. Both of these are in factored form. We set 2x equal to 0, and that's going to result in x equals 0. We can set 2x squared plus 1 equal to 0. Subtract 1 from both sides, take the square root. But we're going to end up with an issue. We can't take the square root of a negative number, so no critical points, just that 0. Okay. We populate f prime with x equals 0. We're going to test value to the left, test the value to the right, plug -1 into the derivative. We get a negative times positive, which is negative, so we know this interval, the graph is decreasing. If I choose 1 to plug into the, to test the right side of the critical point, plug 1 into the derivative, I get 2 positive times positive, which is positive. So the graph is decreasing, hits a relative min, and then increases. So the graph is going to be increasing from 0 to infinity because f prime is greater than 0. Okay, 23. We have the graph of f shown. And it says, which of the following could be the graph of the derivative function? Okay, so let's see if we can kind of create what the derivative graph could look like, and then we can match with the answer choice. So remember, if we're trying to create an f prime graph, your x-intercept is going to be at x equals c. Okay, so I just created some points there. We know the graph is going to be rising until x equals c, and then it's going to be decreasing. So at x equals c, we know that's a slope of 0, and if I have a slope of 0, that's going to be indicating a critical point for my f prime sign line. And then we can see that this is the original graph, so whatever I see is going to be whatever I can interpret with the slope. So positive slope between a and c, and a negative slope from c to b. Now we can also pick out information about concavity based off of this original graph. And if you look visually, you can see that this graph changes curvature from something that looks like concave up to concave down to concave up. Now the x-intercept may not be exactly where these points of inflection are, but just for sketching purposes, I'm just going to mark that as D and E representing my points of inflection. So I'm going to create a second derivative sign line and plot information that I know about concavity. Concave up from A to D, concave down from D to E, right? This is exhibiting concave down, and then back to concave up from E to B. Okay, so if we want to translate this onto a derivative graph, here's my x and y axis. But remember, your y-axis no longer represents position of the graph, it represents the slope of the graph. So anything above the x-axis represents positive slope, anything below the x-axis is negative slope, anything on the x-axis is the slope of 0. So we know there's a slope of 0 at c, so I'm just going to mark c as our x-intercept. And then between a and c, we see it's a positive slope, so we want these points to be above the graph. So can create a region for that. It's going to be above the graph. And then negative slope is going to be below the x-axis. Now moving on to concavity here. If we have a point of inflection, the points of inflection is going to translate onto the derivative graph as peaks and valleys of, or max and mins of our f prime graph. And then the concavity is going to translate to be positive or negative slope. So we want the graph to be positive slope from A to D, hits a slope of 0, hits a relative max, decreases all the way to point E, hits a slope of 0, relative min, and then concave up to indicate a positive slope. And so the graph that's going to best resemble this is going to be answer choice A. Right? These the other ones do not fit that pattern. Okay, 24. The maximum acceleration attained on the interval from 0 to 3 by the particle whose velocity is given as v of t. So maximum acceleration we can find by setting a prime equal to 0 and testing endpoints. So this is applying extreme value theorem. Anytime I want to find a critical point, anytime I'm trying to find extreme value, trying to find critical points for extreme value theorem, the critical points is going to come from the derivative. So the derivative of, it says maximum acceleration, so I'm going to use the derivative of acceleration to help me find the critical point that I need. So I need to find a prime, I need to set a prime equal to 0, and then from there I can find the critical point. From there I can test the critical point and the endpoints, the 0 and 3, plug them all into the acceleration function, and see which one produces the largest acceleration value. So here's my acceleration function after I go through power rule from velocity, 3t squared minus 6t plus 12. Find a prime, because a prime is going to be the derivative that's going to provide me information about the critical point of a of t. So we go through derivative again, 3t squared becomes 6t, 6t becomes 6. Set equal to 0, factor out the 6, find the critical value, which is t equals 1. So we know a prime of t is equal to 0 at t equals 1. That's a critical point. That's the only critical point. And then we have endpoints as well. So we're going to find acceleration at 0, acceleration at 3, acceleration at 1, plug all these t values back into the acceleration function, and see which one produces the largest acceleration. So a of 0 gives us 12, a of 1 gives us 9, a of 3 gives us 21. So between these three acceleration, 21 is the largest. So absolute maximum acceleration is 21 at t equals 3. Okay, 25. What is the area of the region between x squared and y equals negative x? So here's x squared and here's y equals negative x. And we see that there may be a possibility of having confusion as to which region we're talking about. And we know that it's going to have to be between 0 and 2, so that kind of closes it off for us. It's going to start here and it's going to end here, so we're talking about this region here. If I want to find this region, everything is in function form, so I'll go ahead and do top minus bottom. The top function is the x squared, the bottom function is negative x, so x squared minus negative x, that becomes x squared plus x. And if we want to find the depth integral, we have to first evaluate the antiderivative. So go through power rule, x squared becomes x cubed over 3, x becomes x squared over 2. Then we plug in our upper and lower bound. Upper bound gets evaluated first. We get 2 cubed over 3 plus 2 squared over 2. Minus, then we plug in a 0, 0 cubed over 3 plus 0 squared over 2. In this case, 0 wipes out the remaining terms, but just again be careful. Just because we see 0 doesn't always necessarily mean it's going to always 0 out. So just be aware. So we get a third plus 2, which is a thirds plus 6 over 3, which is 14 over 3, and that's our answer.